Okay, 3.3, deductive reasoning. Deductive reasoning is the process of going from one true statement to another, always with a reason, okay? So, you guys watch like murder mystery shows or like any type of detective show, yes? There is deductive reasoning taking place in those, okay? A good old example is like the Sherlock Holmes, or the like new Sherlock Holmes series, okay? You know how Sherlock Holmes always finds these like little, he uses lots of deductive reasoning to come about things. They must have been in China because I see that they have, like a Chinese writing thing on them, or they have this going on, or they, whatever, okay? Things that tie things together. So it's deductive reasoning is the process of going from one true statement to another, always with a reason. So I can get a conclusion because I can know that this is true, and from there I can build on it, okay? A proof. A proof is a series of statements that are supported by reasons, okay? So a proof is what we're going to start constructing. We're going to start constructing proofs. They're a series of statements that are supported by reasons. A reason is why something is true or false, okay? A reason is why something is true or false. And I kind of gave a little example here. This asterisk says, the statement, "It never rains in Texas," is false. The statement, "It never rains in Texas," if a false statement, it is a false statement if you can give a reason why, okay? So, "It never rains in Texas" is a false statement because I could say, I saw it rain yesterday in Texas, or the forecast showed rain, or there was a downpour in Texas, okay? So if I can prove something to be false, then that reason negates what happened, okay? A given is important to know because you're gonna need to know what your given is in all proofs. Your given is something you are told is true, okay? That includes information you see in a diagram. So if you have a triangle and it's labeled like a right triangle, that can be your given. The triangle is a right triangle, given, because the diagram shows that the triangle is a right triangle. So your given information might not be something that's told to you verbally, it might have to be something that you observe from a diagram. Does that make sense? You're always going to start your proof with a given. So when you write a proof, we always have to find the given first. We start with the given information. Now, can I have more than one type of thing from given information, from a diagram? Can I get more than one given information? Yes, especially if I have two triangles comparing them to each other, or two objects comparing them to each other. The angles could be marked congruent, and sides could be marked congruent. There can be separate givens there, okay? So, when we do deductive reasoning, we're going from a process of going from one true statement to another, okay? When I create a proof, it's a process of going from one true statement to another. It is deductive reasoning, okay? From there, I must start with a given, okay? So we're using deductive reasoning to create proofs. We start with a given. This will be on PowerSchool, so don't flip out when I flip this page. Okay. So here's kind of an example of an algebraic proof, okay? So you guys have seen equations where it says 3 parentheses x plus 5 equals 21, okay? That in this case is my given. Do you see how I have statement and reason, okay? My statement is this, my given, or my reason is my given in this one. So the first thing was, they gave me this statement, okay, that was my given. To solve this, you would naturally distribute the 3, yes? So that you get 3x plus 15 equals 21. The reason I got this is because I used the distributive property, okay? From there, you would subtract 15 from both sides, which is technically the addition property of equality. When I subtract 15 or I add 15 and do that, I'm using the addition property of equality. And then you divide by 3, which is technically the multiplication property of equality. But if you put subtraction here or you put division here, I wouldn't mark it wrong. It's the same concept, okay? But I am doing a step and I am backing up my step with a written reason. That's the whole point of a proof. You do your step, you back it up with words. Okay? Proofs often use conditional statements. These are known as syllogisms. Oh, I can't say that word. Yes, syllogism, right? Syllogisms? Syllogism, yes. That's a tongue twister for me, there you go. Okay, so when they talk about syllogism, it's a conditional statement, okay, that backs up proofs. Proofs use these statements to back them up. Okay, does that proof make sense there? You guys have done that type of proof in Algebra 1. You just didn't know you were doing a proof, you know, where Mrs. McCain would say, back up everything that you're doing with a reason. You should have done that in Algebra 1. In Algebra 2, you have to do it, so. Okay, but you should be able to name what you're doing in each step. Does that make sense? We're just going to apply it to the world of geometry. Okay, which means those postulates and theorems are going to come into play. That's why we have to also know definitions, because my reason could be definition of a right triangle, or my reason could be angle addition postulate, or my reason could be segment addition postulate, okay? I can have all of these things. That's why we have to memorize these terms, these postulates and theorems. Okay. Oh yeah, we're gonna try an activity in a second. It says, if you like your teammates, you will train hard, okay? What type of statement is that right there? If you like your teammates, you will train hard? It's a conditional statement, yeah, it's basically a conditional statement. I know it doesn't say then you will train hard, but we can say that's a conditional statement, okay? I made a hypothesis, if you like your teammates, then you will train hard, okay? Conditional statement. This next one says, if you train hard, you will play well, okay? So that could be a converse, right? Because, well, it could technically kind of be a converse, but it's still a true statement, right? If I train hard, you will play well, okay? And then the last one says, if you like your teammates, you will play well. What did I do with those two statements? I combined them. Here's why, okay? And this is something we have to talk about, or that we need to look into. If you like your teammates, you will train hard. Check, okay? If you train hard, you will play well. Check. The third statement says, if you like your teammates, you will play well. So, what happens is, because I know the first statement is true, if I like my teammates, I will train hard, okay? And because I know the second statement is true, if I train hard, I will play well, I can make a third statement out of that. I can use deductive reasoning to say, okay, I liked my teammates, I trained hard, I play well. That means if I like my teammates, I will play well. Okay? Do you get what I did there? Does that make sense? Yes, okay. So you can use deductive reasoning to take prior knowledge to get to the end. Okay? Or to take the beginning and the end and to meet in the middle. Does that make sense? Okay? Which is what we are going to do in proofs. We're going to take the beginning to get to the end. And we can use steps above and combine them to get to where we need to go. Okay? On this website, if we can get there, let's see if it will let us pull it up. So get your computers out and let's see if we can go to EMSCO.com. And last night I tried it and it worked once for me and it didn't work another time. So we're going to see if the website is like working correctly. So if you go to EMSCO.com and you pick your little textbook that we always pick, okay? Our geometry textbook. We are going to look for the activity. If I can get there. We are going to look under reasoning, and we're going to go to deductive reasoning, your first proof, 3.3. If it will pull up, please pull up. I don't think it's gonna pull up, shoot. Okay. If it doesn't work, I think I can go to something else and we can do this a different way. Let me try this. I have another one on my Power School page. I actually have a lot of these proof practices on my Scout Power School page. Okay. We're gonna do a really easy one. We're gonna look at a proof and we're gonna talk about how to do this. Okay, so here is a proof, and this is all on your Power School page. If you go under extra practice, they have just proofs practice and they're easy, medium, hard. This is considered an easy one. Okay, do you see how this proof is set up? It says given, and it tells me what I'm proving, and it gives me a picture. Okay, that's what a lot of these are gonna look like for you. So my given information is what? Angle 1 and angle 2 are complementary, and the measure of angle 2 is 74. So on this one, it says select the statement. So I'm going to select this first statement, and I'm going to bring it over here. And I'm going to check it, because that should be my what? Angle 1 and angle 2 are complementary should be my what? My given. Okay? What else am I going to select next automatically? Yes, the measure of angle 2 is 74, and that should be my given. Okay, so now I've taken care of my two givens. Okay, now I have three options left. Now, we have a postulate that tells us if I have an angle, a small angle, and another small angle, they add together to give me my large angle, right? Angle 1 plus angle 2 would equal the whole angle. Do I have something that looks like that up here? What one? It says the second one. So the measure of angle 1 plus the measure of angle 2 equals 9 degrees. I can say this is 9 degrees because I can look at the diagram and it is a right angle. So I'm going to choose that statement next, okay? Do you see how I'm using logic here to kind of go in order? What would that be considered? Substitution, definition of complementary angles, or subtraction? The second one, the definition of complementary angles, or I could say angle addition postulate. I can use either of those two terminologies to solve that one, okay? Which is why sometimes when we do proofs, we're going to have them set up differently than other people, okay? Now, from there, what do you think I can do? The second one. Why the second one? Because I already know what angle 2 is from my given. So I can select this and say the measure of angle 1 plus 74 degrees equals 90. What did I do when I plugged that 74 in for the measure of angle 2? What do you do when you take someone out of a game? Substitution. You substituted 74 degrees in for this measure of angle 2. So I am using substitution there. And then my last step would be to say the measure of angle 1 equals 16. How do I get angle 1 to equal 16? What do you do with this 74? Subtract it from both sides. And there you have a proof. And you check it. And they say success. Okay? So we are looking at proofs in that instance. Okay? This one was a little bit easier because they gave us options. It was a warm-up. We were practicing. I want to take a look at this one. Okay? And now I made this, so I know the letters are going through the lines, but that's okay. Okay. Prove the theorem AB equals AC minus BC. AC minus BC. Okay? If B is between A and C on a line segment using the segment addition postulate. Okay. Don't get overwhelmed. Just look at the picture. We know that this portion here, this whole line is AC. We know that AB plus BC equals AC, right? Okay. Why do we know that? You know that because of what? What is that called? Well, it's not, well, no, the given doesn't say AB plus BC equals AC. The given isn't that portion, okay? Why do I know AB plus BC equals AC? It is something that we learned prior in chapter 1. Some type of postulate. Yes, segment addition postulate. This segment plus this segment equals the whole. Okay, so here's what we're gonna do. We want to prove what? Where is our ending point? Okay, we want to prove that AB equals AC minus BC. That is my final destination, okay? So that's where I want to go. What is my given? B is between A and C. My given is this. B is between A and C. So I'm going to start with my given, okay? So I'm going to put my statements here. And I'm going to put my reasons here. And my first statement is B is between A and C. And my reason is given. Okay? That's step one. Where can I go from there? What? Would it be like the what of AC? AC. Kind of. You have to give me more. Oh, what did you say? How we know that AC equals what?
BC equals the AB plus BC.
Why?
Because of segment addition question.
Okay, so that's my next statement. We know that AC equals AB plus BC because of segment addition postulate. Okay, because of segment addition postulate. The reason I put it in that form now is this. Okay, think with me. If I want it to say AB equals AC minus BC, that means I have to have some type of equation to work off of. Oh, okay. My equation, I know I can create automatically, is AC equals AB plus BC because I know that's the segment addition postulate. Okay, so I have to have a equation if my end is a equation. Okay, so how would you go about solving this equation for AB? What would you do?
Subtract BC.
Subtract BC from both sides, right? So my next step should say that I am going to subtract. So it would show AC minus BC equals AB plus BC minus BC. I literally show my work. You would normally show your work, yes? Okay, but now I have to back it up with a reason. What am I doing there? Subtracting, okay. Remember how I said when we subtract, that's fine if we put that as our reason, but technically it's called the addition property of equality. Okay, so this, anytime I subtract, it's going to be called the addition property of equality, which is a basic Algebra 1 rule that you should have memorized. Okay, so addition property of equality, or I'm going to put slash subtraction. I will accept either. Okay, so addition property of equality slash subtraction. Either of those solutions would be acceptable. Now, from there, I just want to move this out of my way. Okay, from there, what am I going to do? What would be my final thing? Where am I going? What's your final thing you want to get to?
Subtract.
AC, or AB equals AC minus BC. Do I have that in this form now? Yes, because I can say AC minus BC, these canceled, right? Equals AB. Written this way or written that way, it's the same thing. Doesn't matter. Now, that's my final stopping point, okay? So if that's my stopping point, AC minus BC equals AB, okay? I can, write for my solution a couple of different things. In your book, it's going to say that it's the additive inverse, because they added the opposite of what it was. Okay, the additive inverse, because inverse is negating something, so instead of adding, I am subtracting, okay, so that's where they get that from, additive inverse. Okay, additive inverse. Okay, these are things that you're gonna just have to start recognizing and noticing. Okay, that is how we do a proof. Okay, will this take some practice? Yes. Is this super difficult? No. Not once you know definitions and key terms. Now do you see why I said you gotta know your definitions and your key terms? Okay, let's look at one more. Okay, it says the measure of angle CAB is 3 times the measure of angle DAC. If angle DAB is 52 degrees, what is the measure of angle CAB? Okay, where are we going? What do we need to prove? Yes,
Wait, don't you need to write the given down?
we do need to write the given, but I'm asking to see if we know where we're going in the first place. Do we know where we're going? Where? Okay, I want to end with saying measure of angle CAB equals something, right? Okay, now, what is my given?
DAB is 52.
Good. Measure of angle DAB equals 52. So my statement is here, and my reason is here. Okay. My statement is the measure of angle CAB equals 52 degrees. My reason is it was given. Awesome. Yes, Ellen.
Isn't it angle DAB?
Isn't it angle? Yes. Okay. Good. Okay. So the measure of angle DAB equals 52 degrees. It's my given. Where can I go from there? Look at that picture. You have angle DAB, right here, DAB, and you have angle DAC inside of it and CAB inside of it, correct? Yes.
CAB plus
CAB plus what?
DAC equals DAB.
Good. So what is that called when you add an angle and an angle to get the whole angle?
Angle addition.
Angle addition postulate, perfect. Okay, so she said, let's do this. The measure of angle CAB, okay, the measure of CAB plus the measure of angle DAC, okay, equals the measure of angle DAB, the overall. And that is angle addition postulate, which we also learned in chapter 1. You can abbreviate words if you want to. Okay? So I have the measure of angle CAB plus the measure of angle DAC equals the measure of angle DAB, angle addition postulate. Okay? What can I do from there? You got an idea? What?
I have a question.
Okay, what's your question?
Can you substitute the measure of angle DAB for 52, or you have to keep?
I can, yes.
Okay.
Yes. We are going to do substitution next, so that's great. We're going to substitute 52 degrees in for the measure of angle DAB. What else can I substitute in? Good. So we know that the measure of angle CAB is 3 times the measure of angle DAC. So if I name this x, this would be 3x. So I can do all substitution at once. I don't have to show a step for all three of them. You can, but it takes way too much time and more room. So if you can recognize that I can substitute something in for all of those at one time, it makes my life easier. So I'm gonna substitute this in here. 3x plus x equals 52 degrees. Substitution, okay? Now, how would you solve from there? 3x plus 4x, right? I'm going to show every step, okay? So I would get 4x equals 52. What did I do when you did what? I combined like terms, okay? So I'm going to just write that. Then what are you going to do?
Divide.
So you get x equals what? What? 13 degrees? Okay, and so when you did that, you used what? Division, okay, division. Remember I told you they'll say multiplication property of equality, but we're gonna say division to make it easier. Okay, now, I am not done, because they asked me what? What is the measure of angle CAB? Well, the measure of angle DAC is 13. So I have to take 3 and I need to multiply it by 13. What did I just do there? I substituted again. So I can repeat steps. Okay? So I use substitution again. And 3 times 13 gives me, what, 39? So 39 degrees equals the measure of angle CAB. Okay, and to get that, I did, well, I can just keep this as one step. So if I were to number these, I would say step 1, step 2, step 3, 4, and 5, and then I would make this all step 6 together. So I would have 1, 2, 3, 4, 5, 6 reasons. Yes?
I get everything else, but I don't really get how you got step 2.
How did I get step 2? Because I know that rule. That's how I got step 2. That's why I said you have to know the rules, the postulates and theorems. Here's my advice to you on that. Go online, print off all of my typed up PowerPoint, or typed up definitions, or go on PowerSchool to that AMSCO website and go to each section and print off the postulates and theorems you have used for that chapter, okay? And then that will give you a reference page to go to see those until you get them memorized, okay? This is what you're working on tonight. Yes.